Hello grade 12, Mr. G here once more, and this is going to be a video done about hydrolysis of haloalkanes. Okay, it's another reaction, substitution reaction we are going to be doing, and obviously it may be in the question papers is coming right now. Now, in this reaction, we're going to start with a haloalkane. Remember, this is the organic reactant. It is not going to be the only reactant. That's why I did write the organic reactant. Okay, so in the organic reactant is going to be a haloalkane, and in the organic product is going to be the alcohol. Now you are not going to have only alcohol as the product. Okay, you will always have a haloalkane first, and you will always finish with an alcohol. These are the organic reactants and product. Now in this hydrolysis we have two options. Option 1 is the reaction of haloalkane with a strong base, and we already spoke about strong base. Remember, the strong base is any group 1 element hydroxide. That is a way to identify strong bases. For example, sodium hydroxide. That is a strong base, or potassium hydroxide. All of them will going to be strong bases. Okay. Now, if you have a strong base and you react the strong base with a haloalkane, you will form an alcohol and a salt. All right. Now, the reaction conditions are: first, you need a lot of heat, and second, this strong base we are talking about must be dilute. Okay. Now we are not going to go into details when a substance is to be dilute, but later in further videos we are going to be speaking about acid and bases and when it is dilute and concentrated. Okay. Now this strong base must be dilute. Remember, there was a previous reaction of elimination in which you use the same strong base, but that one was concentrated. So here it is dilute. As a general equation, what are we going to have? We're going to have a haloalkane that is going to react with a dilute strong base, and we already spoke about what are the strong base we're speaking about, and you need heat for this one. The product will be an alcohol and a salt. Okay, so let's see one example so you understand what is going to happen here. We're going to start with this example. This is 1 bromo or bromoethane. You don't have to write 1 bromoethane because in either carbon is going to be number 1. Now the bromoethane, this bromo is going to change places. This bromo here is going to change places with the OH. Remember, we're forming an alcohol. So the bromo that is here will go to the place of the OH, and the OH is going to the place where bromo is allocated. So what do we have in the product? First of all, the alcohol, the 2 carbons, all the hydrogens where they were before, they didn't change. You didn't take any hydrogen away. Here, instead of bromo, we are going to have OH, and that is the alcohol. Plus, what is left? Well, we have the sodium left, and the Br that is then with the sodium. There is the Br. So now we have here the alcohol, which in this case is ethanol, and we have the sodium bromide, which is the salt. I'm not going to write that name. I hope this is understood. It's very, very simple. It's a reaction of a haloalkane with a sodium hydroxide, the strong base, which is dilute, and the alcohol will be formed. This is option 1, in which you have the reaction between the haloalkane with a strong base, which is dilute. Option 2 is the reaction of the haloalkane, but instead of with a strong base, is going to react with water. So this one now is going to be reacting with water, okay, to form an alcohol. So in this reaction, you also need a lot of heat and you need water in excess because the reaction must happen with water. So you need heat and you need a lot of water. As a general equation, we can say that haloalkane reacts with water to form an alcohol, an hydrogen halide. Okay, now we are going to see one example for this one. We have here this compound, which the name will be 2-bromo. The name of this haloalkane is 2-bromo propane. 2-bromo propane plus water. So what is going to happen? The OH here, this OH, is going to change place with the halogens wherever the halogen is allocated. So this OH will go in the place there, and the Br will be taken from there and is going to be allocated in the place where the OH was. Okay, so in the product we have the 3 carbons with all the hydrogens that they have the before. These are the hydrogens that were there already, and here where it was Br, instead of Br we're going to have the OH that is coming from the water. What is left? We have one hydrogen. We still have one hydrogen here, and we have the other hydrogen from the water that is left. Sorry, no, the hydrogen, the Br that is coming from there. So here we are going to have H from here, and the Br that took the place of the OH. So this is the reaction. This is going to be the propanol, 2-propanol or propan 2-ol. It's propan 2-ol. That is the alcohol. So I hope this is understood. This is the whole hydrolysis of haloalkane. It is not that difficult, but if you have any question, you may ask. If you like the video, if you think the video helped, then you can show it by thumb up, and then thank you for watching. Good luck.